Okay, hey y'all. So we're going to be going right where we left off last time. And this time we're going to be starting with the very last initializer, which will be for an R value reference. So this is also extremely important to have because sometimes you just want to do, exacts or something plus offset, so on and so forth. You want to have it, you absolutely should have it, and it's a necessity for any real good vector implementation. So what we're going to be doing is, remember the way an R value reference will be written is and. So super simple, not really much to this one. Uh, Array is temp.array, vector size is temp.vector size, and reserved size is temp.reserved size. And you might be wondering, hey, if I've already written all of this, what's the use of actually having a body for my initializer? Um, well, I'll tell you what, because you absolutely need to delete or not delete, but change what was given to you. So that's temp.array equals, or array equals null pointer. You need to do this. You also need to do temp.vector size equals temp reserve size equals 0. You want to make sure to do some bookkeeping. Very important to have proper allocation. Be very aware of where everything is when you're creating new data structures. Otherwise, you're very liable to have little mistakes that can end up leading to memory leaks. And we definitely don't want that in any implementation. Imagine if vector had a memory leak and every time you were creating a two-dimensional vector, huge in size, that would be quite bad. So now we're going to get on to some more interesting stuff. So by interesting, I'm going to talk about the equals operator, vector p, and operator equals. And the first one we're going to take for an argument is a const vector p and other. You guessed it, setting one vector equal to another. Extremely important. I think no one needs to tell anyone here why this is important. I also realized after the last one, it may have been small for some people, so I'm going to be including this one. Um, so the very first thing you want to do is you want to check, just really quick check. Hey, is what I'm working with right now already equal to what I'm working with and what I'm asking for? Because if so, just return what I already have. Now, you might be saying, wait a minute, Niche, you're using equals equals, and we haven't implemented equals. Don't worry about it. I got you. That'll be later in this time. We're just going to assume that it exists because it will. Uh, Now let's do some, quite frankly, C++ magic, which is quite difficult to understand, I'd say, the first time you see it because it doesn't look real. But I assure you it works and it'll be able to compile by the end of the video. So the very first thing we want to check is, well, second thing we want to check is, hey, is the other vector bigger than this one? Because if it's bigger than what we have right now, then we have a problem because we don't have the space for it. So what do we do? In a regular, if we were using the STL, we would just say, oh, just resize it. The question is, how does something get resized? It's a question that actually does matter and has a lot of implications in how it's answered. So what we're going to be doing now is we're going to be creating a temp array, which is nothing more than a, if you guessed, or I guess I didn't have it pasted anywhere, but we interpret past a T star with a new char of other dot reserve size times size of t. Nice. Um, oh, did I forget parentheses? I did indeed. So, given what I have right, you might be asking, are you using reserve size and not vector size? You just looked at vector size. Well, the thing is, you can have a vector that's reserved for a lot of stuff, but it actually only has a small amount of elements in it. This is not the greatest of answers, I understand, but the reason we're going to be using reserve size is because it ensures the fact that whatever we have will have enough space and will have enough extra space such that any later pushback operations won't cause any needless reallocations. So that's what we're going to be stating. So now we're going to be doing a quick for loop for uint I equals 0, I is less than other dot vector size, because remember these are the actual elements in it. This is what you return vector size. When you return vector dot size, which is what we call it vector size. Not very different, but I think that it suffices. So we're going to be doing our new temp array plus I, which is its location, you know, as anyone who's worked with t of other at I. So this is just copying the elements over, same as if we were using it. Problem is, we already have memory here. So what do we do with the stuff that we already had? So we then do a second loop for uint I 0, well I is less than our current vector size, which is just vector size plus I. Remember, this one was this one was the other's vector size. This one is our current vector size. We're going to be reinterpret casting to t star the array at I and killing it, or destroying it, to be more precise. This makes sure that everything that we have in our current array was properly destroyed. It's extraordinarily important to do. If you just try to overwrite it, we can run into some serious problems. We always want to do proper bookkeeping. Very, very important. So we destroy everything that was already in there. Now, what do? We want to delete our current array. Delete in the same way as we did in our deleter. Interpret cast char star our array. Now, finally, what do? We have an array that's been deleted, and we have a temporary array that's a copy of what we're looking for. So we go array equals reinterpret cast of t star, because remember it was char star, of the temp array. So now we have this. What else do we need to do? We already have the array. Well, we need to set vector size equals other dot vector size. We have our reserved size. We need to set it to our other dot reserved size. And that's it for this. But if you've been paying attention, we had an if statement. What happens if it's less than? That's a different answer. So what we do here, in the case of having a vector that's actually smaller, such that our current vector that we are setting to something else is smaller, we must do something different. And that is for, I need to tab out, for uint I. And if you're wondering why I'm using uints instead of int, it's simply because I just want to have the safety of understanding that it'll always be above 0 and it'll crash the price of it immediately and exactly where it was. You could perhaps use size t, but if I'm incorrect, size t is actually a long or an int64t. So it's just a needless increase in size because I think 2 billion elements is more than enough currently. If you think that that's too small for you, make these longs, whatever you want. Remember, this is just a tutorial, not hard and fast STL laws. I is less than other dot vector size and plus plus I. So what we do is we simply do a this operator brackets on I. We haven't implemented bracket operators either. We will equals other at I. This is simply setting them just as we wanted to. But now we want to delete anything that went ahead of the other vector and that's larger. So what we do is we do uint I equals other dot vector size, which is the size of the other vector, while I is less than our current vector size. And if you guessed bookkeeping, then you were 100% correct. You reinterpret, did I spell that right? Yeah, reinterpret cast to T star, the array, and then you index it at I, and then you destroy the element. What you do then is exactly what you did here, which is vector size dot equals other dot vector size, and your reserve size equals other dot reserve size. Now, here's the catch. You can't just end it here. You have to reallocate. And this is a function that I'm going to be doing just after this because it's extraordinarily important and quite complex. I think a little bit more so than this. Now, in the end, all we simply do is return. And this allows us to set one thing equal to another quite easily. So, hopefully you understood this. Please give me questions in the comments if you don't. But what I'm going to do right now is I'm going to showcase the reallocate function that's here, bracket operators, the equals equals. I think equals equals is quite simple for people to understand, so I might actually go to that first. And then we'll talk reallocate, and then we'll talk, actually, no, equals equals will be simple for other people to think about while we're talking about something that's a little bit tougher, I'd say. Now, reallocate is not something that the public should ever see. It's a dangerous operation to use, and so we use it sparingly, and we don't allow people to touch it, so it must be private. We inline it, make it a void, and we call it reallocate. Doesn't take any parameters. All it simply does is it makes a T star temp array, and we set it equal to reinterpret casted to T star new, not mu, char reserve size times the size of some t, of course. And now that we have our temp array, we must resize. So for uint I is 0, while I is less than our vector size in our current vector, also psi, and we make a new array at this location, and we take its value, and this is the tricky part, we do use the STL here, but only out of necessity, and as a challenge to any watchers, if there are any, I challenge you to implement std move. It's not as difficult as you might think, but I thought that maybe it went outside of the scope of what I was trying to do here. Simply do std move of an array at I. So all we're doing is we're allowing for that value to be coming in and to become a part of our array. And this is extremely important for us because we're moving from one array to another, and this reallocation allows us to keep space and maintain the data structure itself. So what do we do once we've moved this array into temp array plus I? And if you can see how that works, I hope you can. It's because you're starting at 0, that's like array index 0, 1, 2, 3, and we're allowing for the new, which creates array values there, and the T is because it's a T type, and the std move allows for moving from our array into here without any hoopla, basically. Um, we're just going to simply, and if you guess bookkeeping again, you're catching on. Uint I equals 0, well I is less than vector size, plus plus I. The actual array that we're working with, we destroy using the destructor, which is tilde t parentheses. We now delete our actual array, delete brackets, reinterpret cast to t star to char star because we want to delete it just as we do in our deleter array, and we set our array equal to the temp array that we created. So you might be wondering, it looks like we did a whole lot of nothing. Why did we do this? Well, the reason is, if you notice, this char is for reserved size. Sometimes when we want to move to a larger reserved size, we can't just calloc it and expect everything to move properly and just work out the way we want. So instead of calling calloc or calloc or however we want it, we're allowing for a new array to be created with a reserved size that we've specified within the function. If you remember, we've called our reserve size here and set it equal to other.reserve size. You also might remember that other.reserve size is smaller. This is extremely important because it squeezes our elements in. So we do want to have a different sized array. Reallocate is simply resizing our array. So we've done reallocate. Now, I guess the next thing I promised on my list was an equals equals operator. So I'm going to get to that. Let's just do a simple bool operator equals 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 equals, just as any other operator for any class would be in C++. We simply go a constant vector type p given of reference. You can actually take a regular value if you wanted. I'm taking references right now. And simply all we do, if the vector size that we are working with right now is not equal to the vector, or I guess I should have written other, but c'est la vie. Vector size, we return false. So, because remember, vector size counts the number of elements within a vector. So if the vector sizes are not the same, it's of course not going to be the same vector. So now what we do is for uint I equals 0, I is less than vector size, plus plus I. What we do is we check if the array at I doesn't equal the array for vector at the same location. What happens is we return false. Now, the reason I just don't loop through the entire thing and check everything's equal is because this is short-circuiting our loop. This is allowing us to find a singular location where it's not equal and therefore exit our loop early. Just a small optimization that you return false. Or return true, sorry. So I guess you could, excuse me, I guess you could idealize that the only difference between equals equals and doesn't equal is you can just call equals equals on it. Well, you'd be slightly correct, but not exactly. You do want to do the opposite, but to call the same function would be, I guess, slightly less helpful. What you want to do is instead return true, return true, return false. While it's nice to call functions within another, when they're so simple as this, it really isn't something that I would recommend at all. So now, let me remember to make this a dozen. So what have we done? we have allowed for equating one vector to another, and we have allowed for creating a vector from a R-value reference, as well as an equals equals operator. We're quickly reaching 150 lines of code, or 200. Um, Next time, I'm going to go through a bunch of different Boolean operators. I'm probably going to have them written out just because of how simplistic they are in terms of just having the exact same code written just with greater than or less than, with no real differences and things that I think that everyone who's watching this should already be familiar with. I might start the next time up with bracket operators, find, at, and a couple other functions that are a bit more interesting. I guess I should make sure that everything is working. Vector float d equals c for auto I in d std cout I with a space, and then let's make a vector float e that has 5 elements. Yeah, let's test this right now. Let's make a d with 20 elements that's filled with fives, and let's make an e that has 5 elements that are filled with 15, and let's make a vector float f that has nothing given. And what we do now is let's take this, paste it up here, and we have d equals c, and we also want e equals c. We also want f equals c. And actually, this auto won't work, so there's no point in me writing it. So I'm just going to instead write std cout finished and read it in GDB. Make. Oh, I didn't implement the operator bracket. Okay, let's just implement operator bracket. All's well that ends well. So operator bracket is basically the same thing as operator at. It's just a T and operator with brackets given a uint location. We do nothing more than return an array at that location. Definitely not a no except just because, you can get exceptions from it, but the exceptions might happen on your end, so I think it would be safe to do. I'm not sure. I'm going to look into this. I would recommend making it a const, but not a no except. Did I not semicolon? Yes, I didn't. At line 22. Okay. Awesome. So let's GDB into test. GDB test. TUI enable. L. B5. Run. Next. Okay, next. Okay, nothing broke. Nice. Let's print D. So reserve size 10, vector of 10. Even though it started out at 20, let's print E. Same. Let's print F. Same. Now let's go print F at 9. It's 3. Just as we wrote it. Because remember, C had 10 values, all of them 3. The same thing should be here. 9, 3, print D at 9 is 3. And any of them at 10, random value, are PF10. There. We have successfully done an operator equals on 2 vectors. We have successfully done reallocate. Otherwise, we would have had problems with the E. since E had a size that was uh, let's see, smaller. I think reallocate was for smaller, if I'm not mistaken. And then also made sure that everything didn't crash, which is always the number one aspect in coding. Make sure your stuff doesn't crash, because if it does, that's when you have problems. So this dot vector size, when it's greater than the other one, then that's when you use reallocate. So you use reallocate on D and you don't on E, and F was on its own. So everything worked out. We're good. Code will be up soon. Thank you very much for watching, and please let me know if there's any questions that you have. Have a great day. Thank you.